Most of us picture Leonardo da Vinci as a brilliant painter who happened to sketch quirky inventions on the side. We mentally divide his work into two distinct boxes, the artist and the engineer. But that division is a modern invention. Born out of wedlock in 1452, Leonardo was barred from attending formal universities. He never learned the Latin or Greek required to read the era's accepted academic texts. This exclusion became his greatest asset. It forced him to read nature directly, relying entirely on unfiltered empirical observation. He approached painting and engineering as the exact same vocabulary, using both to decode the mechanics of the universe. To actually understand his genius, we have to tear down our modern walls of specialization and see the world exactly as he did, as a single, interconnected system. That integrated approach began to take shape in Florence when a young Leonardo entered the bustling workshop of Andrea del Verrocchio. Verrocchio taught art as a rigorous method of physical investigation. Apprentices mastered geometry to understand perspective, and they studied mechanics and metalwork to physically build the complex items they designed. You can see this visionary approach in his thousands of notebook pages. Written in his famous right-to-left mirror script, these volumes show intricate engineering designs that centuries later would become reality. This drawing illustrates his intense study of biology. He dissected over 30 human corpses to meticulously document the body's hidden architecture. By treating flesh and bone as mechanical levers, his anatomical maps achieved a level of precision eclipsing established medical knowledge. He realized that to paint the human form accurately on the outside, you first had to completely reverse engineer the biological machinery working underneath. When he moved to the court of Milan in 1482, Leonardo began treating his major artistic commissions as practical experiments to test his scientific theories. Look closely at the Last Supper. He engineered the composition to freeze the exact psychological shock rippling through the room after Jesus announces a betrayal. He calculated the geometry of the room to serve the composition, using architectural lines to pull the viewer's focus towards the center of the chaos. In his later years in Florence, Leonardo began a portrait that became a testing ground for his most advanced theories on perception, the Mona Lisa. This diagram explains his technique known as sfumato, or smoke-like blending. By studying optics, Leonardo learned that human peripheral vision doesn't see sharp geometric outlines. He blended his edges to mimic how our eyes naturally perceive reality. And if you look past the famous smile, the landscape reveals his geological observations. Those jagged, eroded rock formations reflect his theory that the Earth was shaped over ages by water, a direct challenge to the biblical timeline. By integrating these layers of optical physics and geology, he produced a work that functions less as a standard portrait and more as a physical record of his lifelong research. Leonardo spent his final years in the French countryside under the patronage of King Francis I, living in high status at the Château du Clos-Lucé. The illegitimate outcast had become a revered royal guest. His unpublished notebooks contained startlingly accurate predictions about plate tectonics, solar power concentration, and the physical principles of flight. He is the ultimate embodiment of the uomo universale, the universal man. This concept stood as the highest aspiration of the Renaissance, celebrating a mind that masters all available knowledge. His foresight looks like magic today, but it was the inevitable result of a strict process. He simply refused to accept inherited authority, choosing instead to test every assumption against physical evidence. Leonardo's example suggests that the most profound insights are waiting in the spaces between our modern categories, accessible only to those willing to look past